Assalamualaikum and good day. We are from Group 5 and today we are going to present Chapter 3, which is Bipolar Junction Transistor or BJT, and our selected topic is Transistor Switching Applications. Before we start, let me introduce you my group members. I am Eva Natasha binti Munisin and my teammates are Isma Hasibah binti Zakari, Nur Nafisah binti Yuzaini, Sumaya Shahidah binti Ilyas, and Umi Umaidah binti Zuraimi. Without further ado, let's begin with the introduction of the topic. Introduction. What is a bipolar junction transistor? A bipolar junction transistor, or BJT, is a current control semiconductor device that plays an important role in analog electronic circuits. It is commonly used for two main purposes, which is amplifying electrical signals and acting as an electronic switch. A BJT consists of three terminals, which is base, emitter, and collector. By applying a small current to the base terminal, the transistor is able to control a much larger current flowing between the collector and the emitter. Why transistor switching? In this presentation, we will focus on the switching function of the BJT. When used as a switch, the transistor operates between two states: cut off, where the transistor is off, and saturation, where it is fully on. This switching capability make BJTs suitable for controlling electronic devices such as LEDs, relays, motors, and many other digital and industrial systems. The objective of this presentation are to introduce the fundamental concepts of the BJT, explain how transistor switching circuits operate, discuss the relevant equation and analysis, and finally explore their practical application in real-world electronic systems.
First, I will explain theoretical concept of BJT in transistor switching application. The basic working principle of a BJT is that a small current at the base can control a much larger current flowing from the collector to emitter. This means that the base acts as the control terminal. The relationship between the transistor current is given by the equation IE equals to IC plus IB, where IE is the emitter current, IC is the collector current, and IB is the base current. Another important question is IC equals to beta IB, where beta is the current gain of the transistor. This shows that a small base current can produce a much larger collector current. For a BJT to operate correctly, it must be properly biased. The base emitter junction must be forward biased, while the collector base junction must be reverse biased. For a silicon transistor, the base emitter voltage is at approximately 0.7 volts. When a BJT is used as a switch, it operates in two main regions. The first region is the cut-off region, where both junctions are reverse biased. In this condition, there is no collector current, so the transistor is off, just like an open switch. The second region is saturation region, where both junctions are forward biased. In this condition, the collector current reaches its maximum value and the transistor is fully on, just like a closed switch. Because a BJT can switch quickly between the cut-off and saturation region, it is widely used in switching applications such as LED control, relay drivers, motor control, and digital electronic circuit. That is the basic theoretical concept of a BJT.
I will explain about circuit operation BJT as a switch. When a BJT is used as a switch, it operates in two distinct regions, cut-off mode and saturation mode. Let's look at cut-off mode, which is the off state. In this mode, no base current flows into the transistor because the input voltage is either zero or below the attenuation threshold. Because there is no base current, the transistor acts just like an open switch in a circuit. This breaks the connection, meaning no collector current can flow through the load. Consequently, the load remains entirely off. On the other hand, we have saturation mode, which is the on state. This occurs when a sufficient input voltage is applied, causing a robust base current flow. This current activates the transistor fully, making it act like a closed switch. With the circuit path closed, a maximum collector current flows freely through the system, supplying full power to the load and turning it on. By cleanly toggling between these two modes, the BJT functions perfectly as a digital switch. Next is circuit components and operations. To understand how a BJT works as an electronic switch, we need to look at the main components in the circuit and how they interact. First, we have the input control signal, which serves as the primary trigger for the system. This signal flows into a base resistor, which plays a crucial role by limiting the base current to prevent damaging the resistor. Next is the BJT transistor itself. Acting the solid state switch, this transistor controls the power going to the load, which could be an LED, a motor, or a relay. Finally, a DC power supply provides the energy required to drive the entire circuit. The operation follows 5 straightforward steps. It begins when the input control signal is applied to the circuit. Next, the base resistor limits the incoming current to a safe level. This current then flows into the base of the BJT, triggering the transistor to switch either completely on or completely off. Because of this stage change, the main collector current is either allowed to flow or is blocked. Ultimately, this determines whether the connected load is successfully activated or deactivated.
Hi, Assalamualaikum. My name is Nafisa, and today I will explain about the result and the analysis of the transistor switching circuit. As you guys can see, the diagram which is the example of the circuit. So let's figure it out how it works in the transistor switching circuit. First, let's look at the condition when the input voltage, which is Vin, is equal to 0 volts. Since there is no input voltage applied to the base current, which is IB, is equal to 0 ampere. And because there is no base current, the transistor does not turn on. Therefore, the collector current IC is equal to 0 ampere. This means the transistor is operating in the cut-off region, which is the off state of the transistor. Since there's no collector current flows through the circuit, no current passes through the LED. As a result, the LED remains off. So, the transistor acts like an open switch, preventing current from flowing from the collector to the emitter. And in summary, when Vin equals 0 volt, the transistor is off and the LED is also off. Now, let's look at the second condition when the input voltage Vin is equal to 5 volts. In this case, the transistor receives input voltage to forward bias, the base emitter junction. First, we calculate the base current using the equation, which is current B, IB equals Vin minus VBE, and we divide it by RB. We substitute the values, and then IB, which is 5 minus 0.7 and divided by 1000, and then which give the approximate 4.3 milliampere for the current base. Next, because the circuit includes an LED, we calculate the collector current using IC, which is current collector, VCC minus VLED minus VCE saturation divided by the RC. And then we substitute the values. IC equals to 5 minus 2 minus 0.2, and we divide it by 220, which give approximate 12.73 milliampere. This collector current is enough to drive the transistor into the saturation region. In saturation, the transistor behaves like a closed switch, allowing current to flow from the collector to the emitter. Therefore, current flows through the LED, causing it to light up. So when Vin is 5 volts, the transistor is on and the LED is also on.
Moving on the practical application, the bipolar junction transistor or BJT plays a vital role in our everyday technology. First, we see them in automatic street light, where a light sensor detects darkness and triggers a small base current to safely switch on high voltage street lights. Second, BJT are used in motor drivers, allowing microchip to rapidly turn battery power on or off to manage heavy electric motors. And the third one, They power industrial relays, acting as a reliable electronic trigger that connects low-power computer signals to heavy industrial machinery safely. In conclusion, the BJT remains a critical element in analog electronics due to its superb capability in current control, amplification, and switching. However, achieving peak performance requires a strong understanding of its internal construction, proper biasing techniques, and current relationships. Selecting the right biasing is essential to maintain circuit stability against temperature fluctuation. That is all from us. Thank you.